Namaskar everyone, I Sumit Kumar wholeheartedly welcome you all to this video. Construction of any civil engineering structure requires various building materials. I hope you all know about this beautiful Havda Bridge. The Havda Bridge is a steel bridge over the Hooghly River in Kolkata. An interesting fact about the Havda Bridge is that it does not have any nut bolt connections. It is built by riveting the entire structure. It consumed about 26,500 tons of steel, and most of the steel was supplied by Tata Steel. You might have noticed that various building materials are used in different structures according to their purposes. Like reinforcement is used in columns, beams or slabs in a building. Various cross section of iron or steel is used in railway lines and bridges. To connect different frames or components, nuts and bolts are used. Depending upon the requirements, steel section comes in different cross sections. If you visit the website of SAIL, you will see various products manufactured by it. Each structural element is subjected to either tensile, compression, impact or some other load. Suppose a vehicle is moving on a bridge and unfortunately it loses its balance and collides with a part of the bridge. Due to collision, the structural component of the bridge may experience some impact load. If the impact load is more than bearing capacity of the steel members, then it may fail and the whole bridge may collapse. Hence, it is always essential to know the property of the material being used in construction. Ductility, brittleness, malleability, hardness are some of the important property of material which are necessary to know before using it for any load bearing purpose. In this picture, a big amount of soil debris can be seen hitting the building. Obviously, when this soil debris hit the building, there would have been some impact load on the building. When a moving car hits an electric pole, it also exerts an impact load. In this video, we will discuss about this impact load, which is related to toughness of the material. We will also learn how to determine the toughness of material through laboratory test. When a material is subjected to any impact load, then it will absorb energy till it yields or fails. The maximum energy that a material can absorb without fracture is known as toughness of the material. The toughness of material becomes an important parameter in case of cyclic loading or shock loading. Toughness of a material can also be defined as the area under the stress-strain curve up to the failure point of that material. The stress-strain curve of a mild steel specimen, which is a ductile material, is shown in the figure given on the left side of the screen. Ductile material undergoes substantial plastic deformation prior to fracture, and brittle materials exhibit negligible plastic deformation. Therefore, it can be said that ductile materials has higher toughness than that of brittle materials. In the laboratory, the toughness of a material is determined by impact testing. The impact test is done in two ways: Izod impact test and Charpy impact test. Before performing any laboratory testing, the first thing you should do is to thoroughly study the relevant IS code. IS 1598 and IS 1757 are the IS code for Izod and Charpy impact test, respectively. The principle involved in performing both the test is same. Only the size and placement of the specimen and applying energy are different. We will discuss the methodology of both the tests in detail. As mentioned earlier, IS 1598 is the IS code that deals with Izod impact testing. Izod impact testing machine consists of a pendulum suspended from a short shaft that swings midway between two rigid upright stands supported on a rigid base. The knife edge or striking edge is slightly rounded, as it can be seen in this figure. The pendulum is raised to a desired height such that shaft makes a right angle with the horizontal. It is supported in the starting position by a catch and can be released by a trigger. The mechanism is so designed that the pendulum is not disturbed when the catch is released. The energy required to break the test specimen is noted. The test specimen of various dimensions as specified in IS 1598 can be used for this test. The most commonly used specimen is of 75 mm length and 10 mm square cross section. The specimen is having 2 mm deep 45° V notch, which is 28 mm from one end. In case of round specimen, 11.4 mm diameter with a 45° notch, 3.3 mm deep is employed. The hammer strike at a distance of 22 mm from the notch. First of all, you have to take the test specimen. Its detailed dimension has been discussed in the last slide. Before going near to the machine, make sure that the pendulum is locked. The second step is to check the friction loss, if any. And the friction loss is checked, as you can see in this video. To check the friction loss, the hammer is allowed to swing free, that is without placing the test specimen. So here it can be seen the hammer is placed at 90° with the horizontal, and then in the machine you can click on the cycle start, then release the hammer gently, and also note there is no specimen placed at the base. Now the hammer will free fall and the energy is noted, which can be seen on the machine. Now here energy is giving 0 joule, that is the friction loss here is 0. So we can note it down as a friction loss as 0 joule. After performing the friction loss test, the hammer is placed back in its initial position and locked. Then the test specimen is placed in its position. The specimen is placed along its length in the groove such that the hammer strikes the specimen at a distance of 22 mm from the notch. It can also be said that the sample is placed in a cantilever position. I hope you know the meaning of cantilever. However, I'll just say a beam can be called a cantilever only if it satisfies two conditions. The first condition is when one of its end is fixed and the other end is free. The second situation is when the beam is subjected to a transverse load, that is, load is applied perpendicular to its longitudinal axis. When these two conditions satisfy, then we can say the beam is in cantilever position. Now coming to this test, here after fixing the specimen at its position, the hammer is released. Here you can see the first, after placing the specimen in the groove, the hammer is allowed to free fall. then it's break the specimen. Now we can note it down the readings as it can be seen here. For this test, the energy can be noted, and here you can see the test specimen is fractured in this way. Now, always after performing the test, the hammer is placed at the position with locking in the locking condition. Now here for this test, the energy is 27.7 joules, and to find the strength, divide the energy with the cross section, then we can get the strength, which is a measure of toughness of the material. Now the test is repeated at least 3 times, and the average energy for failure of a specimen is considered as a measure of toughness of that materials. The Charpy test is similar to the Izod test but differs only in the dimension of the test specimen, its placing position and the falling height of the hammer. As specified in IS 1757, the test specimen used of various dimension as in case of the Izod test. Now in the Charpy impact test, the most commonly used specimen is of 55 mm length and 10 mm square cross section with a notch of a specified depth with 1 mm root radius. The specimen is placed in a simply supported manner, that is, the specimen is supported at each end as shown in figure. So in the Izod test, the specimen is placed in vertical cantilever, but in Charpy test, the specimen is placed in simply supported manner. In the Charpy test, the hammer is at an angle of 145 degree with the horizontal as shown in this figure. But in the Izod test, we saw the hammer is placed at a 90 degree with the horizontal. So if we compare both the tests, we can clearly say the energy in the Charpy impact test will be higher than that of that Izod test. Why? Because the height of the hammer or the free fall height of the hammer is greater in the Charpy impact test than that of Izod test. So here the procedure and observation table is same as Izod test. I hope I was able to explain it in a way, and now you are fully familiar with Izod and Charpy impact test. Now I am leaving you with some questions on this topic. I hope you will be able to answer all these questions. So in the first question we can say, in the Izod impact test, the angle at which the pendulum is placed from the ground. So we read that in the Izod test, the pendulum is placed at an angle of 90 degree from the horizontal. And also in the Izod impact test, the test specimen is kept in a vertical cantilever. And by this impact test, we can know the toughness of the material. So go through all these questions. I hope you will able to answer all these questions. So there are questions. So here one more question is, the toughness value of material A and material B are 60 joule and 5 joule respectively. Which of the following statement is more suitable? So as in the previous slide, we have discussed that for elastic, for ductile material, the toughness is higher than that of brittle material. So here material A is having 60 joule toughness value and material B is 5 joule. So we can say material A is more ductile than material B, or vice versa. We can also say the material B is more brittle than material A. Lesser the value of toughness value, more the brittleness in character. So in the Izod impact test, the notch is we say. Also, one more difference in Izod and Charpy test, that the notching face in the Izod test is towards the hammer striking, but in the Charpy test, the notch face is away from the striking hammer. Now here are some more questions on Izod impact test. For Charpy impact test, there are also some questions. Just go through it. I hope you will answer all these questions. So Charpy V-notch test is done on a building material to determine obviously brittleness. In Charpy, among these options, we can say brittleness, or if there would be ductility, then we can also say yes. We can compare the ductility or brittleness of a material based on this toughness value. In the Charpy tester specimen, the angle of V-notch section is 45 degree, we know, and the specimen dimension is for Charpy test is 55 into 10 into 10. But for Izod test, its dimension is 75 into 10 into 10. So we'll meet in the next video. Keep studying. Thank you. Jai Hind.